Right now, this stalk is dying. Not rotting, worse. Every second it sits here, the sugar— 250 tons of this cane will go through that building in the next hour alone, brace, and every single ton is already losing sugar right now.
"250 tons of cane an hour go in one end of this building. Before a single stalk gets crushed, the load is weighed and drilled.
That core sample goes straight to the lab, and it settles two things: what the grower gets paid, and how the factory runs for the next hour.
The cane doesn't get sliced, it gets wrecked.
A hammer shredder spinning at around 1,000 RPM tears the fiber apart until it looks more like wet straw than wood.
The plant tracks this as the preparation index. A good mat runs above 90%. And whatever you lose here, you never get back downstream.
The shredded cane runs through a tandem of mills, each one a set of huge grooved rollers pressing down with hundreds of tons of force. Hot water goes onto the fiber near the end of the line, and the diluted juice from each mill get pumped backwards to the mill before it.
Run properly, a tandem like this pulls out more than 96% of the sucrose that came in with the cane.
What's left at the far end is bagasse, dry, spent fiber, and it isn't waste. It goes to the boilers, and burning it makes the steam and the electricity. This is what raw cane juice actually looks like. Gray, cloudy, carrying soil, fiber, wax, and plant acids. Nothing about it says sugar yet. Milk of lime goes in first, to bring the acidic juice back close to neutral grins. Leave it acidic, and the heat coming next would start destroying the sucrose. The limed juice is heated to a little over 102 degrees Celsius, and the lime reacts with phosphates already in the juice. This is decolorization. The liquor runs through resin columns that grab onto the remaining color compounds and hold them there. From there, the juice flows into a clarifier and just sits for a couple of hours. Clear juice draws off the top. Mud settles to the bottom. A final fine filter polishes the liquor to a crystal clear state before it moves on to the step that actually removes its remaining color. The mud settling out of the clarifier still has sugar in it, so nobody throws it away. It goes to rotary vacuum filters. What's left is filter cake, and the cake goes back out to the cane fields as fertilizer. Very little of the plant leaves this site as rubbish. Clarified juice is still about 85% water, and to get crystals, nearly all of that water has to go. The problem is that steam boils the juice in the first vessel. The vapor coming off it is hot enough to boil the juice in the second, and that vapor boils the third. Lower pressure buys something else too, a lower boiling point. Keep sucrose hot for too long and it darkens, breaks down, and starts tasting like caramel. Thin juice goes in at around 15 degrees Brix. What comes out is syrup at 65 to 70, thick, dark gold, and nearly ready to crystallize. At the right moment, a measured slurry of fine seed sugar goes in, a known population of microscopic crystals. After that, lime and phosphoric acid go in together, and fine air bubbles carry the resulting flock straight to the surface, where it's skimmed. A centrifuge spins the affination syrup away, and what's left behind is visibly lighter than the raw sugar that came in. The mix inside, crystals suspended in syrup, is called massicwheat, and by the end of a strike, it's about 92% solids and evidence. Massicwheat is loaded into a perforated basket spinning at over 1,000 RPM, and a few 100-gram force throws. A centrifuge spins the affination syrup away, and what's left behind is visibly lighter than the raw sugar that came in. And the syrup that just got flung out still has sugar in it, so it's boiled again in a second pan, and a third. Sugar coming off the centrifuges is warm and still slightly damp, and damp sugar sets into a solid block in storage, then through a cooler, because bagging it warm just makes it sweat inside the bag. Moisture ends up around 1 part in 1,000. Then it's screened. Vibrating decks sort the grain into fine, medium, and coarse, and anything odor-sized goes.
Every hour, all day, all season, samples arrive here, and this quiet room has the authority to stop the entire line.
The clean liquor is boiled and seeded all over again, the same crystal growing principle as the mill,
but starting from a liquor with almost none of its original color left.
Start with polarity. Sucrose rotates polarized light, so a polarimeter reads purity almost directly. Refined grades come back above 99.9%.
And moisture to 1/100%. Grain size on a sieve stack against the customer actually ordered.
Metal detectors check every bag. They are proof tested every shift. A sample from every batch is kept for years. The plant can
Bags are filled by weight, check weighed, sealed, and coded with a batch number that ties straight back to the lab. Bulk sacks get stitched, palletized, wrapped, and stored dry. Leave sugar in humid air and it'll pull moisture out of it and set hard. This raw sugar isn't finished yet. Before it's the pure white crystal you'd recognize, it has one more journey to make, timbre, to the refinery.
This sugar's journey doesn't end at the packing line. It goes everywhere next, starting with a bakery like this one.
A small amount changes texture, browning, and shelf life in ways flour and water alone never could.
One bag, dozens of loaves, every single morning.
In a café, it dissolves into simple syrup pleist, the fastest way to sweeten a cold drink evenly. No granules left to feel on your tongue, trouts, just balanced sweetness. And in its dry crystal form, it's still the simplest option on the table.
Same crystal, two completely different jobs.
Heat it past the point water can escape, and sugar stops being sugar and starts being candy.
No crystals at all now, just a smooth, glass-like sugar sheet.
Cut, cooled, and ready before it even has time to remember it was a liquid.
Same sugar, same 12-hour clock at the very start, just a very different final shape. In ice cream, sugar does something different again. It keeps the mixture from freezing completely solid.
That's why ice cream stays scoopable instead of turning into a solid block of ice. 3 completely different products. One ingredient doing 3 completely different jobs.
And eventually, all of it comes back down to something this simple. A spoonful. That's the whole destination this entire journey was for. And eventually, all of it comes back down to something this simple.